Good afternoon, everyone, and welcome to a webinar hosted by Global Mining Review. We apologise for starting a few minutes late today. We just had a couple of technical difficulties. I hope everyone is managing to keep safe and well in these difficult times. Our webinar today is titled Kinetic Mesh in Underground Operations and Remote Applications, and will be presented by Mike Foletti, Sales Director for Asia Pacific, Darrell Gillis, Sales Director for Canada at Rajant Corporation, as well as Darrell, Chief Technology Officer at Australian Droid Robot. During this webinar, they will discuss using mesh technology in underground mines and tunnels, transitioning the same principles that have made kinetic mesh technology the #1 option for opencast mining to underground. Darrell will then present real-world applications using mesh technology underground for remote inspection, mapping, videoing, and surveying of underground operations, especially in hazardous conditions. We'll have a Q&A at the end of the presentation, so please feel free to type any questions you may have in the question box on the right-hand side of your screen as we go along, and we'll address them at the end. Everyone who is registered to attend the webinar will be emailed a full recording of this session. And now over to Mike, Darrell, and Dawid for their presentation.
Thanks very much, John. It's Mike Foletti here. Before we start, I think it's worthwhile to understand a little about how Rajant kinetic mesh technology came about. As a result of the 9/11 events in New York, it was identified that secure, reliable, and easy to deploy communication networks that could also be mobile were a real requirement. This resulted in Rajant developing its unique kinetic mesh wireless technology, which was initially implemented by the US military. It was then rapidly adopted by the mining industry, oil and gas, ports, and for autonomous and robotic applications. Over the last 14 years, the global mining industry has implemented Rajant mesh networks to support their surface mining operations, with Rajant mesh installed in over 200 sites. Over the last few years, the underground mining and tunneling industry have identified the benefits that Rajant kinetic networks can provide in their own harsh and challenging environments. A significant endorsement has been that Anglo-American mining is now standardized on the Rajant wireless mesh technology for all their global surface and underground operations. We'll now go to the first slide. Today's discussion is going to focus on underground operations that include underground mining, mines that are accessed and serviced via shafts, declines, with many of these accessed from existing or previous open pit operations via a portal. In addition, the large block cave mining operations are also applicable. Civil tunneling operations, including water and sewage utilities, and tunnel construction also have use for wireless networks, especially to support tunnel boring machines or TBMs for their data requirements and in extreme environments that they operate in. Later, our Rajant partner, Droid, will discuss in detail how they have utilized Rajant mesh to support their remote drones and robotic vehicles. These are currently being used for video inspection and numerous other applications in hazardous areas where people cannot enter. Autonomous operations, well, this is especially applicable to block cave mining operations. Notably, these mines require secure, reliable communication networks to support various levels of autonomous load and haul mining operations. Next slide, please. Currently, Rajant mesh wireless mesh networks are only deployed primarily in hard rock or metalliferous mines, but this is also applicable to potash, salt, and other soft mines or similar applications. I understand we do have an installation in South African coal mine, but it's only installed out by, that is, in a non-hazardous location. One of the key benefits of the Rajant mesh technology is that it assists in minimizing the amount of fiber infrastructure required to support a wireless network underground, and of course the additional installation and maintenance requirements that come with a fiber network. The Rajant mesh technology can easily interface or connect to any existing fiber, wireless, or Wi-Fi network already in place. It's also especially useful in providing expanded coverage in the mining, production, and development areas, as these are typically difficult locations to provide a high bandwidth, reliable communications network due to ongoing daily blasting or minimal infrastructure available, especially in new development locations. It's especially useful in providing a high bandwidth mobile communication. It's ideally suited to supporting autonomous mining operations, especially due to the extremely low latency provided, which is critical for autonomous operations. If we move to the next slide, you will see this is a typical layout of an existing wireless network underground, which is based on requiring fiber connections to every device installed to provide coverage. In addition, they traditionally only operate on a single frequency, normally 2.4 gigahertz, and the bandwidth limitations applicable to that frequency. Providing full communication coverage in the stopes, production and development areas can also be quite problematic due to daily blasting and lack of and maintaining infrastructure in these areas. Now, if we go to the next slide, you will see this shows an example of a Kinetic mesh network layout in exactly the same mine. We call our individual wireless nodes breadcrumbs, as they can be easily deployed, connecting wirelessly via multiple hops back to a primary fixed network. Now, the primary differences between the Rajant network topology and traditional Wi-Fi wired networks is there's a reduction in fiber requirements, and AC, DC power is the only infrastructure required to support and operate the network. An ability to easily extend or change network coverage as the mine develops. The ability to have Rajant breadcrumbs installed on production vehicles such as drill rigs, utilities, and dump trucks, providing extended coverage via wireless mesh connections right up into the stopes and development drives. The mobile mesh capability on vehicles and the ease of interfacing to the Kinetic mesh system into a mine's existing fiber or Wi-Fi network makes this a welcome method for providing additional coverage in the mine. That is where existing communication networks have limitations or no coverage at all. Next slide, please. Thank you. What's unique about the Rajant breadcrumbs is that each breadcrumb can be configured either as a mesh node, an access point, a bridge, or a switch, as the network layout dictates, including providing both a mesh and a Wi-Fi access point connection at the same time. Our standard breadcrumbs provide dual 2.4 and 5 gigahertz radios, but we also have 3 and 4 radio versions available with additional frequencies as well. Any Wi-Fi device, such as a phone, tablet, PLC, or IoT device, can connect to the network. Breadcrumbs operate on dual 2.4 and 5 gigahertz frequencies simultaneously, providing high bandwidth and low latency connections. We also operate on full MIMO antennas connections for transmit and receiving for both frequencies. Importantly, we can achieve multiple hops with negligible latency, which we've tested to approximately 0.5 milliseconds per hop. As indicated before, this linear meshing allows the mine to minimize the amount of fiber they need to install on the ground. The breadcrumbs do require a 24 volts DC power supply via an AC or DC connection. Our last point is that there's various types of breadcrumbs available with IP ratings up to IP67 and mil-spec performance, catering for all physical and environmental conditions, including high vibration on vehicles, which are regularly experienced with mining equipment. If we go to the next slide, this is a simple animation that shows the peer-to-peer dual frequency connection for both 2.4 and 5 gigahertz frequencies. Typically, we're using the 5 gigahertz as a backbone connection while still allowing the 2.4 gigahertz to provide a Wi-Fi connection. In either event, either frequency is disrupted or suffers any noise, the other frequency continues to ensure we have a communication link. Now, with our next slide, we're addressing what in any RF wireless network, its performance is as much governed by the antenna selection, installation, and the antenna specs as the radios themselves. To this effect, we've partnered with Pointing Antennas based in South Africa to develop and design a unique dual frequency, circular polarized antenna system, specifically for the Rajant breadcrumbs. These are dual frequency 2.4 and 5 gigahertz antenna arrays. They provide superior performance to any other existing antennas available on the market. They're designed specifically for use in underground mines, in drives, declines, etc., providing significant coverage at distances not seen before with alternative antennas. This includes achieving non-line of sight coverage between breadcrumbs. Darrell will cover this off in a bit later in an overview of some test results performed in one of our existing installations. They're easy to install, including providing a mounting bracket for Rajant breadcrumbs included. This minimized coax connections, cabling, losses, and potential damage from passing vehicles. The multi-frequency bidirectional capability, combined with the circular polarization, provides superb coverage. We've actually noticed that the 5 gigahertz frequency appears to assist in transmitting a further distance in underground mines, rather than just relying on the 2.4 gigahertz frequency. Our next slide is a small animation to show how multiple vehicles fitted with breadcrumbs can be connected together over dual frequencies and extending the network coverage right up into the face. In addition, you can have a vehicle breadcrumb configured to provide Wi-Fi coverage to personnel close by, or available for downloading drill patterns, for example, for drill rigs. Mine surveyors and geologists have found having Wi-Fi coverage at the face allows them to update plans, take samples and update their data without having to wait till they return to the service. This greatly improves their efficiency. Included in this slide, you can show a leaky feeder cable in yellow. This has been included just to raise the fact that we can connect the Rajant wireless mesh network into any existing leaky feeder voice system. So we're able to transmit and provide coverage with comms with two disparate systems. I'll now hand over to Darrell Gillis to provide an overview of wireless mesh and shafts and some different applications utilising the Rajant Kinetic mesh in other underground operations.
Good morning. Shaft sinking. Wireless belling seemed to be one of the first applications that was used for using mesh in a shaft. Back in the day, back in my day, the miner would reach out of the bucket and grab a cable to do the belling to the hoist room. Pretty dangerous practice back then, and was eventually eliminated by using wireless belling. So the belling push buttons are now inside the conveyance, and the signal goes through the mesh to communicate to the hoist room. By having 100% coverage in the shaft, you eliminate the hoist being kicked out when there's a loss of comms. That's just a common safety feature. Having mesh in the shaft also allows for video feeds on the Galloway, Wi-Fi voice, tablets, ground monitoring sensors, and safety sensors. Next slide. This is Redpath's method of using our mesh in the shaft. They've been doing Rajant mesh systems for 4 years now. They installed it in all their shaft sinking and shaft rehab projects. Their combination of leaky feeder and coax cable make sure they have 100% coverage, and actually kind of gives a lot of redundancy between the breadcrumbs. Next. Autonomous and semi-autonomous. Obviously, mesh is being used in dozens of open pit mines for autonomous control of trucks, shovels, and drills. So it's an easy transition for underground applications. Most applicable use case is using a mesh network to control a scoop or truck between shifts to keep the ore passes full and allow skipping between the shifts. Also, extending the range for radio remote controls and teleop would be another easy application to use Wi-Fi for. Next slide. Voice applications. To me, this is a pretty important factor of using our mesh. You can tie into obviously existing Wi-Fi voice systems. We can also tie into the leaky feeder radio system by bridging on surface the voice channels. This is pretty common. It's certainly not new technology on surface. It's certainly being used in a lot of industrial sites. When you use a push-to-talk app on the phone to call, your signal goes through the mesh to surface, that is bridged and rebroadcast on the radio channel. And then vice versa. The combination of portable and fixed breadcrumbs also finally allows emergency alerts to broadcast over both systems and right to the miner of the face. So by having breadcrumbs on the machine, you're actually reaching the, and so being mobile on the machine as well as being fixed, you actually reach the actual face. We're actually working with a company called Orion Labs as well. They have a very slick app that allows personal cell phones for push-to-talk application on Wi-Fi. We hope to test that the next couple of weeks, actually, in a shaft. Next slide. Wi-Fi tracking is already an established technology on surface. It's everywhere. Bringing it to underground in the past was pretty difficult because there really wasn't the infrastructure to allow it. Now with the mesh fiber connections, it's certainly an easy application. The advantages of tracking are well known for safety, production, ramp optimization. I mean, you can go on and go on and on. Also, with COVID and the importance of contact tracing, underground tracking could become critical, especially for mines, remote mine sites. Next one, please. Data applications. This is pretty common for a Wi-Fi system, but the advantages of using fan controls, air quality monitoring, data from substations overheat, geotechnical sensors. There's so much you can put on an established Wi-Fi system just because it's an off-the-shelf solution. Fan controls are obviously a very easy payback system, which you can turn your fans off between shifts, and you're looking at usually hundreds of thousands of savings per year. Next one, please. Remote work sites. So Alamac raises raise bore locations, underground diamond drilling. They're usually in the middle. Most of these sites do without comms just because it's usually a temporary area and usually don't have any data transfer whatsoever. So using a mesh network and plugging into the nearest switch and hopping to these sites allows for voice and data communication between the miners and surface. In the case of Alamac raises, we can actually hit the basket using an antenna, which really hasn't been done in the past. And also, since they're mostly done by contractors, after the job is finished, the contractor can pick up the breadcrumbs and move on to the next site. Next one, please. Now, installation examples. We have multiple mines in South Africa due to being standardized with Anglo-American, as well as numerous shaft installations with Redpath, and one in Brazil underground and one in Mexico underground as well. Next, please. This is just a level drawing of the one in Brazil. It's kind of showing you where the breadcrumbs were located. I believe in some of the curved ramp areas, we used a similar solution to Redpath and used some coax just so if there's no line of sight, we could actually have 100% coverage. Next. This is a Panelists mine in Mexico. Same thing, showing the breadcrumb locations. You can see from some of the non-line of sight numbers, they're getting anywhere from 100 meters to 300 meters. And of course, each mine would be different. It depends on the location of the breadcrumbs and what kind of antennas, etc. Each mine, of course, we could tailor to design the fit to each application. think the main thing these presentations have shown that we can use existing backbones. We have an easy way of reaching the face with mobile and fixed breadcrumbs. And the large number of applications you can put on a wireless Wi-Fi mesh. And that's the end of my part of it.
Thanks, Darrell. It's David Perley here from Australian Droid Robot. Good morning, everyone. I'll give you a brief overview of who we are, what we do, run through networking, what it does for mining operations in terms of automation and remote inspections. We'll look at some production improvements from case studies we've done with automation. I'll run through why traditional networks is not ideal for our applications, some shortcomings, and I'll give you some examples of autonomous and remote inspections underground that we do here in Australia. So Australian Droid Robot, we are developer, manufacturer and service provider for autonomous remotely operated systems above ground, underground and on surface. Our company motto is about separating people from hazards. So to provide safety by separation of operators from hazardous environments through teleoperation and autonomous systems. If you see the hierarchy of safety, we fit in between substitution and engineering. So remove the person from harm. And some pictures of some services that we offer. So networking, what it does for mining. This slide pretty much sums it up. So typically underground environment, everyone thinks it's very hazardous and unsafe. So let's remove the operators. This slide is above ground. It shows 2 LHD operators remotely operating the vehicles and the shift boss is standing behind them monitoring everything. So live data coming from underground, they can see meters moved, tons moved, efficiencies, exactly where all the vehicles are located and what the operators are up to. So you don't have to communicate to your staff through noisy two-way radios to figure out what's going on below you. So networking, what does a proper network do for an underground mining operation? It provides a platform to complete tasks remotely and autonomously, where we can separate the people from the hazardous environments. But more than this, it enables you to get real-time data that you can capture and analyze. So this is 2 example photos of a mine automated by my business partner, Joe Cronin, sitting on the bottom right here, looking relaxed. It's in North Parks here in Australia. So bottom right is the mission control station and bottom left is one of the operators operating one of the vehicles. So this operator is not seeing any vibration through the machinery, is not exposed to dust, for instance. It's a safe environment. So some benefits of automation in mining is we'll use 2 case studies that we were involved in. One is Syama Gold Mine and the other one is North Park Mine. If you look at Syama Gold Mine, 15% operation cost reduction, 21% increase in drill meters per day, and 24-hour truck operation. North Park's mine here in Australia, 20% increase in production output, 24% higher LHD productivity, and 23% reduction in cost per ton. So as well as offering safety benefits by removing you from hazards, there's also clearly financial and operational benefits involved with going through automation, which a proper network enables. So for our applications at Australian Droid Robot, started maybe 6 to 8 years ago, and we tried all networks out there, but we've come to the conclusion that office networks are simply not suitable for this environment. 1, they are not rugged, and 2, they're not designed for high throughput and relay of live data and video from mobile equipment, which requires seamless managed handovers. The safety systems, in our experience, will trip if you have a latency of more than 200 milliseconds. And we found it, the operators find it difficult or impossible to operate machinery teleremotely if the latency is more than 300 milliseconds. This, in our experience, drops down to about 100 milliseconds in the case of a small agile vehicle like underground drone or rover. So this slide just shows you an example of a case. What this graph shows you is on the left-hand side, it's the signal strength, and the different colors is just different access points. So The latency between handover between the access points causes machines to stop. And because the machines are dynamic, these are not stationary objects that you can tune the antenna position and the wireless network to perfection. They move. And a drop in signal strength here will cause your automation machine to stop for safety purposes. So this is where intelligent meshing and routing provides higher reliability for safety and production critical tasks. This brings us to what we do at ADR, so remote inspections underground, and examples where we use the Rajant mesh network underground. There's a whole handful, and by no means this list is not the entire picture, but I'll give you some more examples in detail about stope LiDAR scanning, seismic re-entry, draw point monitoring, and abandoned mine re-entry. If you're interested in any of the above, just please get in contact with me and we can run through it with you in detail. So mesh networks, this is a job we did for a seismic event. So typically we get called in if something goes wrong at a mine. And as you can see here, this is our drop bear inspection vehicle in front of a whole bunch of rubble. Part of that rubble was the infrastructure, so it makes it really difficult to depend on a network if you need to go down there if something happened. And the beauty of the Rajant dynamic mesh network is we can get down there and establish our own mesh network. Or if the mine is already equipped with a Rajant dynamic mesh network, we can extend that in real time using our mobile nodes. So our toolkit of what we use for remote inspections typically consists of a base station, which we equip with a Rajant mode, normally a ME4 or a DS1. And then we have a handful of vehicles that we can pick from, some rovers and some airborne, like a drone. Each one of these vehicles are equipped with a Rajant breadcrumb node and in effect becomes a mobile network node. And the beauty of Rajant gear is you can almost plug and play any IP related sensor onto the vehicle and see it through your base station. So I'll run through some examples of where you can use this inspection kit. A job that we did here in Queensland for the government is inspecting an abandoned mine. And this case kind of highlights one of the questions we get a lot. So why can't you just use a normal RC car, strap a GoPro to it and go and inspect your mine? Well, the answer is quite simple. One, the RC car is not designed for the environment. And two, your RC signals only go so far beyond line of sight. So this is where a mesh network comes in handy because you can go beyond line of sight. So if you have many routes to your endpoint, you can establish a mesh network and get there. So on the bottom left is the portal entry of the abandoned mine. That's me with the base station. And then the end goal is we want to get the drop bear, which is our high zoom, high quality inspection camera vehicle, to where we want to be. So what we do is we connect one rover to our base station, drive it as fast as we can, line of sight, park it on the corner. This becomes our first node. We then extend the network or the reach by driving a second rover with a mesh network on board. And we continue that exercise until we have a fully established mesh network. In this case, it took about half an hour to establish a network. So once we got that, then we can send a high detail camera in using that mesh network to do our inspection. Second example is stope scanning, laser scanner on board a drone or rover. And the stope is just a large excavation that's unsupported. And the mines are very interested in it for volume and dimensions so that they can do a production reconciliation. But due to the hazardous nature of it, you can't exactly send a person in there with a laser scanner to scan it. So this is where remote vehicles really come in handy. So in this case, if we go to our toolkit, we'll have our base station, we'll have a rover, line of sight to keep the operators safely away from the hazard. And then we'll fly our drone, we'll bolt an IP laser scanner to it, and then relay the mesh off our rover. So the ground robot acts as a node in the kinetic mesh to relay real-time data between the ground station and drone in the stope. The inspector, which is our drone, captures LiDAR and camera data to characterize the excavation. This is sent back in real time to the operator at the base station. Much simpler application is just an as-built infrastructure survey. This example, we did a pump station scan. In this case, you just have your base station and you have your rover with a laser scanner attached. So again, it just keeps the person away from harm. Draw point inspection, something people are very interested in, is if you get a hung draw, you need to go and see what's happening. In this case, you can see exactly want to be the person below. So you do not want to be the person standing there when that happens. It'll be scary. So in this case, rover was there and no one got harmed. And another example of a draw point inspection is with a drone, in this case, the inspector. Let's go back. And that was the draw point inspection with a drone. That was equipped with a DX2 Rajant node, and the view you can see here was through a GoPro, HDMI converter, through Raspberry Pi, and then through IP. And that live view you see, so high detailed, almost no lag view that a pilot can use to inspect pretty much anything they desire to inspect. So I'll leave you with that. Thank you. And I'll hand it over to John.
Okay, excellent. Thank you very much for that presentation, guys. We've now finished the presentation section of the webinar, and we'll start our Q&A momentarily. If you haven't already, I'd like to encourage people to type their questions into the sidebar on the right-hand side of the screen. These can be anything, really. They can be company specific or more general questions about kinetic mesh. So our three speakers, Mike, Darrell, and Dawid, should be on the line with us now. Can you guys hear me okay?
Yes.
Yeah, I can hear you. Yes, John. Thanks.
Excellent stuff. Before we get stuck into our questions, I'd just like to remind everyone that you will receive a full recording of the presentation via email after we've finished today. So you'll be able to recap and watch again at your convenience. So without further ado, let's begin with some questions. I have a question here from Tracy. She says, how do you achieve such low latency? Are you using standard Wi-Fi for backhaul or a proprietary system? Sorry about that.
Yeah, John, it's Mike here. Yes, the Rajant system is a proprietary system, and we don't use the standard 802.11 protocols for managing the actual data and transmission. The reason being is the 802.11 protocol is designed to be generic, and we operate at layer 2 level, so we're able to manage how we process the data and transmit between our radios. And that's the other important point, is that both radios are integrated into one device, so it's not two separate radios and then being tied together. There's also management of the CPUs and the data and how that's managed. Again, all built into the proprietary protocol. Plus, we use, in most cases, we may use the 5 gigahertz for the backbone and use the 2.4 for providing local Wi-Fi connections, or we could use both, depending on what the status of the signal noise is and how good the signal connection is. So it's really around the proprietary nature of the technology.
Okay, great. Thanks very much, Mike. We have another question. I think this one is also for you, Mike. It's from Andy. He just asks, what is the max number of hops?
Yeah, that's a good question, because that's one everyone asks. As I indicated, we've measured it at around 0.5 milliseconds per hop. It depends on how many applications and how much data and throughput you want to do, but you can imagine any system will have inherent latency. Let's call it 5 milliseconds or 10 milliseconds or whatever the case is. You then can say 10 hops will add another 5 milliseconds to that. And you can continue on and work out as to what's acceptable. I mean, you could use, say, theoretically 20 hops is going to introduce, another 10 milliseconds of latency in our network. You then have whatever applications and multiple applications that you're running on top of that will dictate what the actual number of nodes you actually can, or hops you can put in place. Obviously, you like to try and have some redundancy and an additional fiber connection somewhere. But it's really up to the individual mind to decide how they want to deploy it and how many hops they want to implement.
Okay, thank you very much. I have another question here from Sabata. I hope I'm pronouncing that correctly. She says, regarding voice application, are there specific devices to be used with mesh?
Darrell, do you want to?
Specific devices? No. I mean, really, it's anything that that allows either VoIP or Wi-Fi. So no, there's not specific. You don't need specific phones or radios or whatever you're using. It's pretty well universal.
Okay. Thank you very much. I have another question here. Again, I hope I'm pronouncing this name correctly, from Kirill. They say, please, can you elaborate a bit more about handover? What do you use to improve latency?
Yeah, as I mentioned before, it's due to the proprietary protocol that we use. But we actually have a white paper that addresses this specific question, and we can make that available for Kirill after this webinar. If you can send me his details, and I'm happy to pass that through to him.
Of course, yeah. I'll make those details available. That's not a problem.
Yeah.
So we got a few more questions. Let's have a little look. We have another question from Tracy. She says, do any of the ADR robots / drones make MSHA approvals? Or sorry, have MSHA approvals, that is.
Yeah, currently not that I'm aware of, but if that is something that you are generally interested in, please reach out to me and we can work together to make things happen.
Yeah, just for that, on that point, MSHA approval generally applies to intrinsically safe environments within the US, coal, but there are also some MSHA requirements within hard rock or metalliferous mines in the USA as well.
Okay, thank you. We have a question here. I can see that Darrell's already responded via text, but we have a question here just for the benefit of everyone else listening from Prashant. Again, I'm really sorry. I hope I'm pronouncing that correctly. They say, what tech is used for personal tracking underground? Is it Wi-Fi based or GPS based?
Definitely Wi-Fi based.
Okay, short and sweet. Okay, we have another question from Sabata. They say, are we able to integrate Tetra or DMR radio network?
To tell the truth, I don't know enough about those kind of, or the differences between that and a normal analog or digital, but I mean, it's a standard bridging. So yeah, I mean, I'm sure it would.
Okay.
Yeah, I believe with Tetra is a digital leaky feeder system, and it would utilize a similar integration method as what we currently do with a leaky feeder.
Okay, thank you very much. We have another question here from Karel. They say, does the Kinetic mesh system need a controller, appliance, or software?
No, that's a very good question. That's one of the significant benefits of the Rajant technology, is we have no controller or separate network management device or application running, which is standard and traditional with all other mesh networks or versions thereof. The reason being, each individual Rajant breadcrumb effectively has its own intelligence built on board and makes real-time decisions on routing signals and communications and deciding which frequencies to use in real time, whether it's 2.4 or 5 gigs. These are based on, basically it does what we call a cost analysis of how much noise, signal strength, etc., and will make a decision in its own time on its own basis as the best way to manage the traffic as such. And as a result, we don't have any lag or requirements for an external application device to manage the network.
Okay, thank you. We're getting a lot of questions flooding in now. I hope we'll have enough time to get through all of them. I have a question here from Todd, who asks, how is AHS operating on the system?
I think he's referring to automated haulage systems. We're currently working with mine in Australia and with Hitachi for a surface-based application using the Rajant mesh application for automated haulage systems. In the underground, we're in discussions currently with mines in Australia, some that have David's mentioned, that are currently block cave operations and already running autonomous operations and looking to improve their network utilising the Rajant mesh over what they've done today. They had to rely on traditional standard Wi-Fi, and that required a lot of infrastructure to enable it. So I hope that answers the question at this stage. Anyway.
Okay, great. Thank you very much. Another question here from Olivier, who asks, does each hop of the wireless mesh operate on its own frequency, or do all the nodes share the same channel for the mesh?
That's a good question. They select the actual frequency they require, which is, as I said, it's done on a cost analysis basis, and channels can be allocated as required. Again, that's depending on the topology, the applications. You can implement multiple VLANs and provide priority on those VLANs for the applications you want to have priority. But again, it's a question I can get somebody with more technical expertise to answer for you later.
Okay, thank you very much. We've got 4 new questions. Hopefully we'll be able to get through all of them. We've got a question here from Jeff, who says, does Rajant use layer 2 or layer 3? And does it support standards-based interfaces like 802.3 and 802.11, so it can interoperate with any standard Wi-Fi or Ethernet device?
Yeah, that's a good question again. I did mention before that Rajant utilises layer 2 networking, so we're not required to align ourselves with the generic 802.11 protocols, but what it does allow us to do is that we support the standards-based interfaces like 802.3 and 11, so we can interoperate and connect with any standard Wi-Fi device in client mode or via an Ethernet connection.
Okay. We have a question here from Benjamin. He asks specifically, are the breadcrumbs MSHA approved for use in coal or gassy metal / non-metal mines?
No, not at this stage currently.
Okay, thank you very much. Next question from Oscar. He asks, did you do tests with multi-polarized antennas?
We have test results for the existing ones, and I would have to refer back to my colleague in South Africa who did the development of pointing antennas and all the development and the testing. So I would have to get back to you on that answer specifically.
Okay, that's not a problem. There's another question here. This is Darrell just following up on a question about whether the Kinetic mesh system needed a controller appliance. They just wanted a bit of clarity. They just say, so no controller, is it decentralized?
It's decentralized from the perspective that each breadcrumb or Rajant wireless mesh node manages how it transmits and signals and data and traffic. So yes, it's decentralized, for a better word, if that's what you wanted to use.
Okay, thank you very much. We have a new question here from Denny. They just ask, how long can the drone fly for in minutes?
That's probably for me. So that depends on your payload. If you got a simple optical sensor on board, you can go for roughly 40 minutes, 40. If you got a 2-kilogram laser scanner on board, you're probably looking at around 20 minutes.
Okay, thank you. We have another question here from Juan, who asks, what is the best VSWR recommended for circular pole antennas? Usually VSWR is less than a 1.5 to 1 ratio to avoid lateral and auto interference, and then avoid issues with latency and issues with other networks running closely.
The easiest way for me to answer that is I can provide a technical data sheet which has all that information listed on it for the pointing antennas.
Okay, thank you very much. And we have our final question here. This is from Carol, who asks, what are the batteries capacities in your devices and how long can they operate for?
I'm assuming that's for me as well. So our rovers, we typically run on 12-volt batteries. Capacity is anything from 5 amp hours up to, say, 20, 25 amp hours. The drones, we run about 22.2 volt systems, and you're looking at about 10 amp hour battery plus.
Okay, thank you very much. And if I may, I'd just like to add one question at the end. What would be the value of installing Rajant mesh radio on underground vehicles?
The benefit. Do you want to go ahead, Darrell?
Yeah, sure. Really, the tracking, the telemetry off the machine in real time, the mobile aspect of the creating the mesh. I mean, there's certainly a lot of reasons to put it on mobile vehicles, whether it be a jumbo, a scoop. But the amount of sensors we do on surface for trucks and shovels, I mean, there are hundreds. I mean, tire pressure, oil pressure, overheating. So using that same philosophy underground is, yeah, definitely cost effective and could be the way to go.
And okay. I'd like to add, it also assists in providing coverage up in the working areas and the faces where you can't have infrastructure installed for blasting every day. So you can have vehicles effectively creating a mesh up into those work areas, and especially in development panels where there is no infrastructure at all. So yeah, they allow you to extend existing fixed network via the vehicles, creating a virtual mobile network up into different areas where available.
That's great. Thanks, Mike. And thank you to everyone. I think that just about wraps up our Q&A session. I'd like to thank Mike, Darrell, and Dawid for today's presentation and for their time at the Q&A afterwards. And thank you to everyone who attended today. Again, I hope you're all managing to keep safe and well in these difficult times. If you'd like any further information or have any follow-up questions, inquiries can be directed to the team at Rajant. If you're not already receiving a copy of Global Mining Review magazine, please visit our website at www.globalminingreview.com. Click on the magazine tab and fill out a few details to register for free. Just another reminder that everyone who signed up will be able to receive a full recording of the webinar via email once we've finished. Global Mining Review is actually hosting another Rajant webinar in 5 days' time on the 19th of May, titled Choosing the Right Network for Your Mine. We'd be delighted if you could join us for that. That's if you'd like to learn the steps that the pros take and the features that they look for in evaluating and deciding which technology to implement to ensure reliable performance now and scalability for the future. Also, don't forget to like and follow our Facebook, Twitter, and LinkedIn pages for all the latest news and updates from the mining industry as events continue to develop around the world. Thank you again, everyone, for coming, and have a great rest of the week.
Thank you.